How much have I plagued myself in this way? This quote by Albert Einstein is referring to when this intellectual phenom was trying to pair his theories on relativity and quantum mechanics together. Yikes, it hurts me just thinking of the subjects. But this article, which was written by George Musser in the Scientific American June edition, is about the theories and how they have been applied to spacetime and how certain aspects of spacetime have been questioned and brought back up in the recent span of years. One of the biggest problems that physicists face is that gravity is so powerful. However, even something as small and as simple as a kitchen magnet holding a paperclip can defy gravity. This leads people to come to the understanding that it is not as strong as magnetism or nuclear and electric forces. The only thing that people can point to in the form of an experiment on the matter is a black hole. A black hole is a very strange and interesting subject of space. It looks as if it's a three-dimensional object, but it acts and behaves as a two-dimensional object. One big hole in the theory of quantum relativity is that it predicts that matter falling into a black hole will be infinitely compressed into a cul-de-sac called singularity. But the timeline for said piece of matter ends there. The term there is also an issue because the space-time that would show the location of said singularity does not exist in reality. This is the big thing that researchers are pushing for in the experiments. They are trying to use quantum theory in a microscopic fashion to try and pinpoint that exact there of the matter that gets sucked into a black hole. Another strange issue with the physics of the black hole is that outside of the hole, the gravity is weaker, and researchers believe that the regular law of physics would hold. However, with the event horizon at the mouth of the black hole, the movement of the hole is irreversible. What is strange about this is that all the theories of physics and even quantum mechanics state that these physical movements can be reversible. But when in the event horizon, nothing can be reversed. Stephen Hawking made a discovery in the 1970s pertaining to the thermodynamics of black holes, but that even worsened the problem with trying to find a cure for irreversibility. Once this issue is resolved, scientists will be one step closer to having a new foundation on the phenomena we refer to as spacetime. The author used several different terms in this very, very long article. One of the three that was most prevalent throughout was authoritative research. Authoritative research isn't the term though, authority is. Authority is defined as an individual considered to be an expert. The author also used opinions in the article. An opinion is defined as a viewpoint that may or may not be supported in fact. The author also used deductive reasoning to try and bring the reader to a conclusion. Deductive reasoning is defined as drawing conclusions based on connections between statements that serve as premises. George Musser used authority throughout the article by citing many different experiments and statements done and made by world-renowned scientists such as Stephen Hawking, Albert Einstein, Ted Jacobson, and the list goes on and on. He also used opinions from said people to add fluidity into different subjects on the matter that the article was pertaining to. Most of the statements used in the article also fall under the term deductive reasoning. Deductive reasoning, as I have already stated, can be defined as drawing conclusions based on connections between statements that serve as premises. He uses these statements as a way to provoke the reader into coming to his or her own conclusion on the matter. The reader will weigh the thoughts and opinions on the various sources and formulate opinions of their own.